Assalamualaikum and very good morning. Because I'm from Ahmed.co, a company that produce methanol. So, this is our CEO. I'll start from me, myself, Tengku Rifki bin Tengku Mahmud, matrix number 191876.
Okay, my name is Yohan Jin, matrix number 192145.
And my name is Nur Aizalaika binti Zulkifli and my matrix number is 192359.
So, in our project, we need to methanol production for our plant design in the energy balance cost. So our requirement is to do a production rate of 250,000 kilogram per hour, 80% of purity of methanol, and produced from methane. In introduction, raw material, we should use methane in the beginning, but it is highly cost and very expensive, so we prefer natural gas, which have a high composition of methane. And for our product is methanol. In our plant design, we consist of 4 units, which is steam reformer, methanol reactor, flash drum, and distillation column. And our newly added units is heat exchanger and furnace.
Okay. So I will start from process flow diagram. Okay, this is the whole process flow diagram of our design, and then we will input the natural gas at 50 degrees Celsius and 7 atm to PRV, which is a pressure regulating valve, and then after that we will enter furnace to heat up our stream to 650 degrees Celsius at 1 atm, and then we will enter steam reformer. After that, we also will add steam to our steam reformer for the reaction to occur, and the catalyst we use is nickel oxide and magnesium oxide, and then the condition is at 800 degrees Celsius 1 atm, pressure at 1 atm, and then the effluent gas will after that cool down by the cooler, and then after that we will enter a compressor. After we increase the pressure through compressor, we will enter methanol converter, which we use Cu as a catalyst, and the condition is 250 degrees Celsius at 80 atm pressure. So before enter flash drum, we will decrease our pressure first by pass the stream through PRV, and then after that we will decrease our pressure by passing through cooler. So after that we will enter flash drum, which the condition it will operates at 60 degrees Celsius and 5 atm. And then before enter distillation column, we will pass through PRV to decrease the pressure from 5 atm to 1 atm. And then our final units, which is distillation column, we will obtain products which have 80% purity.
So for the assumption, in the pressure regulating valve unit, so our assumption is we assume that it is in ideal gas state, so the delta H approximately to 0. And the compressor unit, we assume that only include shaft work and frictionless. For the flash drum, we assume only methanol and water at the bottom stream, which is liquid stream, and no other species. For the distillation column, we assume all methanol and water inlets are in liquid phase. And for overall, we assume no heat loss when processed steam passing through the pipe.
So now I will proceed. I will start for the first unit, which is electric furnace. The code of this electric furnace is FRU001. The function of electric furnace is actually to heat up our feed, which is natural gas, from 50 degrees Celsius to 650 degrees Celsius. And from the name, we can know that it is operate by using electricity instead of fuel, which because electric furnace are more efficiency and is eco-friendly compared to fuel operating furnace. And the power rating is 50 kilowatt. And before we enter electric furnace, the stream will enter PRV first to decrease the pressure from 70 atm of our natural gas to 1 atm. And this is the power. The power that we require is 3,800 kilowatt. So after that, the stream will proceed. It will go to steam reformer, and then the code of steam reformer is ST001. The function of steam reformer is to produce syngas from methane syngas, which consists of CO, CO2, H2, and this is the chemical equation, which H2 CH4 react with H2O will produce CO and H2, and CO will react with H2O to produce CO2 and H2. And this syngas actually is the gas that we needed to produce methanol. And this is the heat reactions of the first and second chemical equation. And the input temperature to the steam reformer is 650 degrees Celsius at 1 atm, and we also will input steam to steam reformer, which is at 650 degrees Celsius 1 atm. And the steam reformer will operate at 800 degrees Celsius 1 atm with the help of catalase, which is an nickel oxide, magnesium oxide. So the output stream will be at 800 degrees Celsius and 1 atm. The power that we calculate is 4,600 kilowatt per hour. So next unit. Okay, the cooler we use is actually to cool down the stream from reformer, because the effluence from steam reformer is 800, and we have to input 252 degrees Celsius to the methanol converter. So we have to install a cooler to reduce the temperature, but at the same pressure, which the inlet is 1 atm and outlet is 1 atm. The cooler, actually we use water as coolant, and the functions of cooler is actually is a heat exchanger, and heat exchanger is a unit that transfer heat between two fluid without mixing, and our coolant is water. So the water will absorb the heat from the stream and then will release. So the power that release is from this cooler is 9,200 kilowatt, and the amount of cooling water that we use is 15,000 kilo per hours, and this is the equation that we use to calculate the amount of cooling water we use.
Okay, so for the pressure regulating valve, we use pressure reducing valve to reduce the input pressure of a fluid to a desired value at its output. So how it function, the pressure rises, which pushes the diaphragm, closing the inlet valve to which it is attached and preventing any more gas from entering the regulator. And as the gas is drawn from the outlet side, the pressure inside the regulator body will fall. So this is why we use the pressure regulating valve. And the code that we use for our design is PRV 001, PRV 002, and PRV 003. So for the compressor, we use compressor to compress the pressure to increase the pressure of the stream from 1 atm to 80 atm. So after we calculate the work shaft, and the power that we got is negative 0.4313. So we continue to the methanol converter. Methanol converter we use to convert synthesis gases such as CO, CO2 and H2 into methanol. So the code that we use is MT001. The inlet temperature that we use is 252 degrees Celsius, and the outlet temperature is 257 degrees Celsius, and the pressure is still the same, 80 atm. And the power that we got is negative 1778798. So for the cooler, we use the cooler to cool down the stream temperature from the methanol converter. So the inlet temperature that we use is 257 degrees Celsius, and the outlet temperature is 102 degrees Celsius. The pressure is still the same, 5 atm. So the power from the cooler that we get is 1830.139, and the amount of cooling water that we use is 308,61514 for the mass, and the heat that we get is 6588501198.
So next is flash drum unit. Flash drum function is to separate unwanted gas from methanol and water before entering the distillation column. So the process is like when the input getting into the unit, it will become two outlet stream, which is upper product and bottom product. Upper product usually the lighter one, which is in vapor state, and the bottom product is liquid state, which is heavier. We proceed to PRV before entering the distillation column. So in this flash drum, the input temperature is 102 degrees Celsius, while the pressure is 5 atm, and for both of the output stream, pressure is the same, which is 5 atm and 60 degrees Celsius temperature. The heat energy that we calculate is 16.9 to the power of 6 times 10 to the power of 6, and the power is 4712 kilowatt. Next is,
Okay. You mentioned the
before this we use absorber, but in this balloon we replace it with flash drum because the absorber is quite complicated, and it's also expensive and highly cost. Need spend a lot of money. So we prefer flash drum, which is easier to proceed to the next unit. So next, it is distillation column unit. Okay, distillation process to purify crude methanol by removing impurities. The distillation column unit code is DC001. So from the flash drum, proceed to the PRV first to regulate the pressure from 5 atm to 1.03 atm, which is approximately 1 atm to ease our calculation, and the temperature remains 60 degrees Celsius. The input is like that, and the output is 82 degrees Celsius and pressure 1.03, which is approximately 1 atm for both output stream. So the product stream is at the upper stream, and the bottom stream will be waste stream. So the product stream, our product is in vapor state, and our heat energy is calculated by 8.7 million kilojoule per hour, and for power is 2437 kilowatt.
Okay, so now I proceed to costing, and okay, this is the overall costing that I've calculated. So for raw material, our feed natural gas, we have done a research and we estimate the cost of the feed for next 20 years, and then we conclude that we get the result that the maximum cost fluctuation will be 72 millions and the minimum cost will be 34.9 million ringgit per year. And our catalyst costs about 4.34 million ringgit per year, and total up for our raw material costing is for minimum feed price is 39.2 millions and maximum feed price is 76.3 million. And our utilities consist of cooling water, steam and electricity, and the total cost is 256 million. For the cooling water, it costs 253 million ringgit per year, and the steam is 299k ringgit per year. The electricity is 2.88 million ringgit per year. Total is 256 million ringgit per year. So for our labor, plant overhead and laboratory costing is we plus the utility cost and raw material cost, we times with 0.2 and we get 59 million ringgit per year. So our total operating costs will be this will be the price. And then for the cash flow, as you can see, we earn money at the from the first year to until 20th, and this cash flow we will be estimate the revenue of our company for 20 years, and this graph show that the maximum price of it, and we earn money from the first year to the 20 year, because we in our costing we didn't include capital cost, which is the cost for our units and pipe. So that's why it can be seen that we earn money from the first year. Actually, supposedly for company, they will have a payback period for about 4 to 5 years. And then this is the cash flow for the minimum price of feeds, and then also the same we earn from the first year.
Okay, so for the conclusion, our company methanol plant is to produce methanol with 80% of purity and 250,000 kilogram of methanol per day. So we produce our methanol from methane, which we get it from our natural gas. So each unit in our plant is play very important function. So we start from steam reformer, methanol converter, flash drum and distillation column with complete heat exchanger and furnace. So overall, we design our plant economically without using extra cost for unnecessary processes. So our recommendation for the future of our company, is to increase our production rate so that we can make higher income in the future.